Hello dear students, welcome back to Learn Physics. In today's video, we are going to discuss about the chapter Laws of Motion. Okay, so here in Laws of Motion, last class we discussed about some exercise questions. And in today's class, we will be discussing some more exercise which are very important to your entrance exam center. Okay, so here it's given two inclined surfaces, and this side angle is 60 degree and this side angle is 30 degree, and here we are giving two masses. Both the masses are attached with a string. This is attached with a string. This is A and this is another one B. And these masses are attached to a pulley and which is connected to another mass C. Okay, now we need to find out the acceleration of the system. First find acceleration and then find tension in the string. Here it is given mass of A is 1 kilogram, mass of B is 3 kilogram and mass of C is 2 kilogram. Okay, so here in this inclined plane you can see that both the sides are at different angles. We need to find out A. For finding A, the formula is net force acting on the system divided by total mass. First, our aim is total mass. It's easy to find out. First, our aim is to find out the net force acting on the system. See, we know that mg will be acting exactly downwards. But according to the inclined plane, because here if I am considering the plane and this is the point, this is where A is kept, and here mg will be acting exactly downwards. But this side is making an angle 60 degree. Okay, so mg with respect to this inclined plane, we can divide it into two components. See, I am dividing one component like this, next component like this. Okay, this will be balanced with the normal reactional force from the surface of the object or weight. So only this one will be remaining over here. And if this is theta, see this is an inclined plane, and if this is theta, we can find it as the other side. This side also will be theta. Okay, so this is equal to 60 degree. While we are dividing it into two components, mg cos 60 and this will be mg sin 60. Same way, if I am considering for through the inclined plane, which force is acting, which component will be acting for B? Same way, sine 60 component will be acting for B also. And now we are considering. Now I am going to consider for third C. Here, when I am considering the inclined plane, I will be getting it as, see, the other side inclined plane. How I can find out? This is C, which is making an angle 30 degree, and here C is kept over here, and mg is acting exactly downwards. So how can I divide this into its components? One is here mg, this is making an angle theta. If this is theta, this also will be theta degree only. Then here it is dividing it into components like this. Okay, mg will be exactly acting downwards and one component will be acting here. Sorry, another component will be acting in this direction. Okay, so here the total component, the total force acting on the system. How can we find out the total? There's G, this is sine 30. Okay, so clear children, here how we are getting mg is exactly acting downwards and dividing this into respective components. One is acting here and another is acting in this direction. So this is theta, g, here it is cos sine 30 degree. Okay, sine 30 degree We are getting it over here. Now we are going to find out the total force. How can we find out the total force? Total force acting on the system will be equal to mg sine 60, and here one mg sine 60 acting like this, another mg sine 60 acting like this, another mg sine 30 acting like this. So mg sine 60 plus m of a, next is mb g sine 60, then here in the just opposite direction sine 30 is acting, therefore we can give that as minus mc g sine 30. So when I am considering m as 1 into 10, sine 60 is root 3 by 2 plus mb, it is given as 3 kilogram, 3 into 10 sine 60, we can write it as root 3 by 2 minus mc, it's given like 2 kilogram, 2 into 10 into sine 30 is 1 by 2. Okay, so when we are solving this, we will be getting it as 24.64 Newton you will be getting. This is the total force acting on the system. Then how can we find out the acceleration? Acceleration equals total force divided by total mass of the system. Mass of the system is 1 plus 3 plus 2, that is equal to 6. Therefore 4 point something you will be getting 4.1 meter per second square. Okay, clear children? So we are considering the components over here. Total force divided by total mass. For that, we are considering this into components, and here the right side and left side, both the sides into components we are dividing, and then finding out the total acceleration of the system. Okay, next our aim is to find out the tension in the string. To find out the tension, how can we find out the tension of the string? First we will consider for A. Okay, this is A, and when I am considering this tension in the string, mg will be acting, this mg sine 60 will be acting downwards, and tension is acting in the upward direction. Okay, so it is moving with an acceleration downwards. Okay, next is here T1 is the tension. How can I find out the T1? Here it is m1g sine 60. We already told, right? m1g sine 60 minus T1 equals mass of A into total acceleration. So here T1 equals m1g sine 60 minus m1a. What is m1 here? m1 is 1 into 10 sine 60 minus acceleration. We already got it as 4.1. You can solve this. Next is the same way tension in the other side. How can we find out the tension in the other side? Here C through, this is C, it is making an angle 30 degree. Here it is acting through G sine MC G sine 30 degree, and here tension is acting in the opposite direction. So the same way when we are considering minus T2 plus mg sine 30, sorry, T2 minus mg, acceleration is acting in this direction only, right? So here T2 minus mg sine 30 equals ma, mc into A. Here also mc. Therefore T2 we will be getting it as mca plus mcg sine 30. M already we got it as 2. 2 into acceleration 4.1. 10 into sine 30 is 1 by 2. While you are solving, you will be getting it as 18.2 Newton. Children, please check, are you getting it or not? Here next is another question is given. What should be the acceleration of the box? We need here acceleration is given here. Here it is acceleration. The figure is given like this. This is a box. Inside that mass A. Okay, and it is accelerating downwards. What should be the acceleration of the box so that the block of mass m exerts a force of, m gives a force of mg by 4 on the floor of the box. So here this was given a mass of mg, force of mg by 4 to the ground. Then we need to find out the acceleration. How can we find out acceleration here? We know that mg will be acting, force acting downwards is mg by 4, it is given. Usually we will take mg only. So here it is normal force. It's not given that mass of the A alone. It is not given like that. So normal reactional force is acting upward direction. So here we can write it as mg by 4 minus n equals ma. Right? Here we need to find out the mass of the system. Mg by 4 minus n equals ma. Therefore, we need to find out the what should be the acceleration. Acceleration, how can we find out? A equals g by 4 minus mg by m equals acceleration. Therefore, g by 4 minus g, that is, we will be getting it as 3g by 4. 3g by 4 is the acceleration which is acting on the system. Okay, normal reactional forces just exactly balancing with the force which is acting on this downward direction. So now another diagram is given here. See, how can we find out the tension in this? Here a pulley is given. In that pulley, at this side, we can a mass 2 kilogram is given, and here another mass 1 kilogram is given, and here you can see another forces. This is 3 kilogram, and this is another one is given it as 4 kilogram, and all the tensions are marked over here. This is T1, this is T2, and this is T3. We need to find out the tension acting on the pulley. Okay, tension which is acting, which are the given tension T1, T2, T3, and all we need to find out. So tension, usually before finding out the tension, we will find out the acceleration. Acceleration, how can we find out? Net force acting on the system divided by total mass. What are the forces we need to consider here? Here this M4 is acting downward direction. Mg is here also acting downward direction. And here the force is acting in the upward direction because it's pulling downwards. This also acting upward direction. Now tell me, 4 plus 3 minus 2 minus 1. Right? This is the total mass, this into acceleration divided by, now we can consider the total force acting on the system as 3 plus 4 plus 2 plus 1. So here 7 minus 2, 5 minus 1, 4 into g divided by 10. So answer is 4 meter per second square as the acceleration. Now we are going to find out the tension. First, here tension is in which direction tension will be acting. Tension will be acting in the upward direction. Right? Tension is acting upward direction. So here acceleration will be acting downward. Therefore, mg minus, first one for 4 kilogram when I am considering, mg minus T1 equals mass into acceleration. Therefore, T1 equals 4a, mg minus 4a. mg minus 4a. M is given as 4 into 10 minus 4 4s are 16. So, answer will be 24 Newton. Okay, 24 Newton we will be getting here. The same way we can find out for the other masses also. Then T2, how I can find out? The same way T2 is acting in the upward direction. So, here mg 3 into 10, then T1 is acting in the upward direction and T2 also acting. What will be the T1 acting here? 3 kilogram is here, T2 acting in the upward direction, and the reactional force for 4 kilogram is acting downward direction T1, and here acceleration is acting downward direction, mg is acting downward direction. So 30 plus T1 minus T2 will be equal to 3 into A. Okay, therefore T2 we can write it as 30 plus T1 already we got it as 40 minus 3 into 4. So here 54 minus 12, you will be getting it as 42 Newton. Next T3. In the same way, first we will mark all the forces acting on the system. 1 mg is acting exactly downwards, T3 is acting downwards, upwards, acceleration is acting upwards. Therefore, we can write it as T3 minus mg will be equal to mass into acceleration. T3 equals mg plus a. mg1 into 10 plus acceleration, we got it as 4 only, right? So here it is 14 Newton. Okay, clear children? So this is how we will be finding out the total force or total tension acting on the string. Okay, so hope this is clear for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.